now I have 2 copies of everything, okay? So then, if we look at 3, it says homologous chromosomes together, which I have, right? What does homo mean again? Same, right? So we've got the same chromosomes, one from mom, one from dad, that we've replicated. So it says we want to line up on the middle line. What phase is that?
Oh, that's metaphase.
Metaphase, right? Okay, so I'm going to set these up on the middle line. And then, here's where you get to draw on the tables, which is exciting. Anyone remember what these... Spindle fibers, awesome. Okay, we got our vocab down. Okay, so they're going to attach to the chromosomes. And then, what's going to be our next phase?
They start kind of like separating.
Anaphase, yeah, they're separating, they're moving apart, which is going to lead us to cytokinesis, okay? So with anaphase, they're moving away, okay? And now we have the cells splitting with cytokinesis, like you were saying, Cynthia, okay? So now I have 2 cells, okay? So when I look here, how many chromosomes do I have in each cell? So I've got 2 cells, and how many chromosomes in each? 3 pairs, right? What did we start out with? 3 pairs as well, right? So we're back sort of where we started at this diploid point, okay? So remember, but the same thing happens again, because we're going to end up with 4 cells, and we're going to end up haplogroup. Is this cell the same genotype as this cell? How do we know? Right, these colors are different, right? So we know that these came from mom and these came from dad. Are our mom and dad genetically identical? No. Okay, so that would be weird if they weren't, right? It would not be our mom and our dad. Okay, so now these are separated, okay? So I have just taken us through meiosis 1, okay? So I want you all to try to go through meiosis 1 and then finish it off and go through meiosis 2. How many cells should we have when we get to meiosis 2? 4. Okay, and then there's going to be some more questions to think about genotype and how do we get different genotypes in the cells. Okay, so some chalk. There should be these chromosomes sort of separated out, and see if you can act out the process. Okay. So we should be looking at best farmer, y'all. Yeah.
Wait, can I get the
cows? Yeah. Dominant or recessive?
$1. I'm not either. Okay, wait.
I know, big D. Big D. Okay. So if we're going to say call it B for large, so what would be our genotype be then?
And that's where we both get
For the data model.
first we need.
Okay, is that the only option?
It should be like the same size too. This one.
What do we call that when it's big D?
Why are the blue ones smaller?
Right? Okay, so you need to make 200 squares.
I'll just cross it.
Okay, they're both big. They can have different
No, we need one.
squares because you're going to have to do
Is it the same size for you?
Yeah.
For me, it is. I don't know why. The little ones too bigger.
Okay, so what do we know about UV?
Yeah, that was better.
Okay, and then you need more? Or? No, we need more. The small ones. The small one, okay.
That works hard to say, right? Did you see the picture?
Well, you replicate that. Remember, you get more.
And what was replication again?
Huh?
What is replication again?
When you copy it.
Okay. You guys are at that stage.
So, is this a dominant or recessive?
Kind of the same size.
Okay, recessive, right? So if it was dominant,
Okay.
it might be a lot more, right? Okay,
Which is
okay. If you look at the blue one, it says homozygous.
and that's how we draw the spindle
Why
fibers.
is it telling us okay, so they can pass it on. What is this? Two little
And now that's those 2 cells, right?
Yeah, so now.
Okay, so they could have the
The same process.
right? Remember it says heterozygous, so they can
In
have
the same cell. Yeah. Okay. So then, do we like take that away and then do it again?
meaning they, we don't know what the genotype was. Okay, and we may not even know
Start
what
over again.
the genotype
Wouldn't you replicate them again?
So, what we noticed
Because I know we had four right there, but we're no, it has to be.
right, so maybe she had it or mom and dad both.
Yeah, I think you replicate them again.
Grandma would never got it, right?
Yeah, then we replicate them again to the so which would be two brown. Yeah.
Okay, but in the article, did it say anything about where these people
And then wouldn't it be blue instead? Because you gained it from the mom and the dad. You would replicate the cell. Okay, but then we got three. But then when you do it again, so you got blue, so you just switch it. So they could replicate
Okay, so why is that?
wouldn't it be the same chromosome?
Okay, but why does that really make you think?
Because it's the same thing as the process from
Right, so if blue is common in some of your family members.
Yeah, because this is okay. This is perfect too.
If I went out
That's cover. Yes. Yeah, and then look at the way they are. Can you come here quickly?
Oh yeah.
What do you need? Okay,
Okay.
Would you replicate the same?
Okay, so does replication happen in between meiosis 1 and meiosis 2?
So what do you do? Wait, this whole circle.
Yeah.
So then where do they kind of begin?
Right, exactly. So it's almost like the same process again, except for replication doesn't occur. Okay? So we have replication occur before the whole meiosis process, but not again. Exactly, Sophia. Exactly.
So that means only this will be one.
Yeah. So then these, right? Keep going.
I like this. And then. And then it would split off.
Yeah.
And that would be that meiosis 2.
Right. Okay. So we get these separated. Then what happens up here?
It gets separated.
Yeah. Okay. So move them away a little bit more so it's easier for us to see. Okay. Okay. So now we've just done anaphase 2, correct? Okay. So now what happens?
Isn't that where they No, and it's cytokinesis.
Yeah, okay. Cytokinesis. Right. It takes a little bit for us to keep them straight, right? So the cells split again. So can you draw for me where these cells would split?
It would split in the middle.
Yeah, exactly.
So it would be 4 cells. But
Yes.
it would have its abnormal. Yeah, it's very hard. It's okay.
It's okay. The shape is not really what it is. It's just us not having awesome drawing abilities.
There you go.
Okay.
Have 4 cells.
Okay, so now we have 4 cells, which is what we were expecting, right? Okay, so now what's going on inside the cell chromosome-wise? Do we have the same amount, less than when we started?
We have the same amount still, just no, there's 3 in each still, but just now one only has 1 parent, the other one only has.
Okay, so instead of having the pair, we only have 1 in each, right? So here's a cell. Okay, so I'm trying to draw this a little better so you can see. Okay, the squares are cells. So we have 4 cells, and in each cell we have 3 chromosomes. One half of the parent. Yeah. Okay. So now we've ended up with the haploid cell because we have half of what we started with, right? Okay. So are the genotypes of each of these cells the same?
No.
Okay. So if we then mate, right? There's a chance that you could get this gamete or this gamete, right? And these would produce different offspring, right? So remember how we talked about with like our siblings, we look different, right? So maybe like my sister, right, looks super different than me. If you remember seeing her last year, right, with the olive skin and the brown hair, like maybe she got these genes and I got these genes, right? And that's why we look so different.
So these will come, they go away and go look for another pair and just do the same thing again?
So no. So what happens is now this is in like in woman, right?